Hi guys, so today we're just going to be doing a review lesson on kind of starting to bridge the gap between fractions and decimals, and I thought maybe you guys needed a review of how we can go about doing this. So to start off today, we're going to look at a decimal, and we're just going to remind ourselves of our decimal place values. So here we have 14 and 251 thousandths. Remember our first digit right after the decimal is called our tenths place. It's called that because our tenths place is split up into 10 pieces. It takes 10 tenths to make a whole. Then we have, of course, our hundredth place. Again, even smaller pieces. It's 10 times smaller than tenths. These pieces are split into 100 pieces. It takes 100 hundredths to make a whole. And then lastly, we've talked about our thousandths place. Again, smallest pieces of these three split into 1,000 pieces. It takes 1,000 thousandths to make a whole. Now, when we start talking about the relationship between fractions and decimals, we always want to start looking at our denominator. Now, our denominator tells us how many pieces something is split into. And in order to make a fraction into a decimal, it's easiest if our denominator is either a 10, 100, or 1,000. The reason for that is because those are our decimal place values, tenths, hundreds, and thousands. So if you're changing a fraction into a decimal and it already has a 10, 100, or 1,000 in the denominator, then you basically already know what the decimal is going to look like. For example, this first fraction is 31 hundredths. So you would write the decimal the same way, 31 hundredths. Same thing. It's the same form because our denominator is 100 in this case. So either 10, 100, or 1,000. Really easy to turn a fraction into a decimal. The way that you say it is the way that you write it as a decimal and a fraction. Now, we're going to look at some other examples where it's a little bit different, but it's not too much harder. The first example we'll look at is a fifth. Remember a fifth, we have a 5 here in the denominator. That's not one of our decimal place values. What we can, though, do is we can find an equivalent fraction that has a number besides 5 in the denominator. Ideally, we would want it to have either a 10, 100, or 1,000. So it's really easy to make a 5 into a 10 by multiplying by 2. We'd get 10. But whatever we do to the denominator to keep our fraction the same, we have to also do to the numerator. 1 times 2 is 2. So we could say 1/5 is the same as 2/10, which would look like this. So 2/10 is the same as 1/5. Now, when we're working, that will work anytime we're working with fifths, by the way. You can always change the denominator to 10. When we're working with fourths, you'll notice, again, we don't have a denominator that's a 10, 100, or 1,000, but we do have a way to make it into one of those. Now, there's no denominator or there's no number times 4 that will give us 10 because 10 is not divisible by 4, but there is a number times 4 that will give us 100. And if we think of quarters in this case, if you think of how much quarters worth, you can multiply by 25. 4 quarters is $1 or 100 cents. We do the same thing to the top. We can figure out that 1/4 is the same as 25 hundredths. And again, if we go back to writing our decimal, it's going to look like 25 hundredths. Think about how you read that decimal, and it's going to be really helpful. Now, when we're talking about eighths, we again do not have an eighths place, but we have a tenth, hundredth, or thousandth. We can actually turn eighths into thousands. An easy way for me to remember this is an eighth is a half of a fourth, or in other words, it's a half. Remember, a fourth is a half of a half. So an eighth is a half of a half of a half. So I know a fourth out of 1,000 would be 250. So an eighth is half of that. So it's going to be 125. So multiply by 125, multiply by 125, we get 125 thousandths, which looks like this. 125 thousandths is the same as 1/8. Now, anytime we can change the denominator into a 10, 100, or 1,000, we're going to make it significantly easier to change it into a decimal. Now, If that is not possible, such as this last case here, we do have our backup strategy, which I want to remind you of. If we have a third, 1/3, remember this fraction bar always means to divide. So in other words, this is saying 1 divided by 3. So the way I would write that is like this: 1 divided by 3. And I'm just going to add a decimal and a 0. That's still worth 1. 1 divided by 3. I would say how many groups of 3 are in 1? That's always going to be 0 here, as long as this fraction is below 1. And then I'm going to say how many 3's in 10? That's going to be 3. 3 times 3 is 9. Subtract 10 minus 9, I get 1. And if I get a remainder, I can always just continually add zeros because it's still worth 1. Bring it down, bring that 0 down. I get 10. How many 3's in 10? Again, 3. And you're going to notice this point that this is repeating. Now, when you divide a fraction, you're looking for one of two things. The fraction is either going to terminate, it's going to end, it's going to stop, or it's going to repeat. Anytime we find a repeat, we always want to put a line over the part that's repeating. For example, 1/3 is going to be the same as 0.33333333333 forever. So we want to put that line over the top to show that those threes are repeating. Now, you can use, remember, this division method for any of these. For example, if I wanted to use it for 1/4, which we just did a second ago, 1 divided by 4, put down my decimal. How many groups of 4 in 10? That would be 2. 2 times 4 is 8. 10 minus 8 is 2. Add another 0, bring it down. How many 4's in 20? 5. 5 times 4 is 20. And we're done. Notice 1/4 is 25 hundredths. And it was 25 hundredths when we used the other method too. You can always use that division method in order to change a fraction into a decimal if that's the method that you prefer. Now, one more thing before we finish that I want to remind you of is what if we solve something like this? Remember, this is an improper fraction. 6/5 tells us that it's more than a whole. So I know that 5/5 is a whole. What I would do in this case is I would just first say, well, this is the same as 1 whole with 1 extra fifth. Then you can just change that 1/5 into a decimal, which would be the same as 2/10, which means 1 and 2/10, which means this would be the same as 1 and 2/10. So if you see something like that, it's probably easiest to figure out how many wholes there are first, and then change the leftover fraction into a decimal. That might be a good method. So going back, think about what we did here to change each of these fractions into decimals, and using these methods, you should be able to change any fraction into a decimal by using these.